Hello friends, welcome to Coding Garden with CJ. Welcome to Code Katas number 23. If you're new to the show, you can visit GitHub where I have all of the code and links from all the katas I've solved in past episodes. It's github.com/codinggarden/code-katas. You can click on today's date to see the katas that I plan to solve. Before we get into it, let's say hello to all the wonderful people in the chat. It's a little light tonight. I didn't announce this ahead of time, but that's okay. Hello, Daniel Garden. Welcome to the stream. And hello, Pranjal from India. Facundo, hello. And Joshua, welcome. And El Barate, welcome, welcome. El Barate has a question. I'm having trouble with an API. The docs are only showing AJAX commands, but I need to make the request in the HTML. Interesting. Like, if you're going to make the request, you still have to do it with JavaScript. This leads me to something. So I started a repo called Free Debugs. I haven't done a free debug show yet, but the idea is you could submit an issue to this repo, and I potentially might help you figure it out live on stream one day. There's only one issue right now, which I haven't taken a look at yet. So if you want to submit it here, I maybe can help you out. I'll share that link there. And hello, RabbitWorks JavaScript. Welcome, welcome. Hello, Andrew Lane. Hello, Koi. Hello, Yossi. Hello, Brayson. From Peru. That's awesome. Denny says, sup, dog. Hello, full stack developer. It is Subin. Hello, Subin. And Alicia. Welcome, welcome. Emiliano, all the way from Argentina. Hello. Cool. So I have a few katas picked out for tonight. In order of increasing difficulty, the first is a 7Q called Remove the Minimum. I then have a 6Q, which is called Title Case, a 5Q, which is Rot 13, and a 4Q, which is called Strip Comments. Without further ado, let's get this started. So typically what I like to do is pull these down locally. So I'm going to create a file locally called Remove the Minimum. And we'll get our blank function in there. And some of our test cases. Let's see. Oop. Okay. Actually, I'm not going to log these comments, just going to log the input and the expected output. Okay, we'll start up Quokka, which is a neat little tool that will run the code inside of my editor. There we go. This is throwing an exception. Let's not do that. There we go. Okay, so right now our function is returning undefined. Awesome. Alka made it. Hello, Alka. Welcome, welcome. And Danielle, welcome. And hello, How, who says it's 1:25 a.m. in Brazil. It's going to be a fun night. Don't watch too long. Try to get some sleep tonight. Full stack developer is asking, what does CJ mean? CJ is an abbreviation. I was named after my father, so I'm a junior, C junior. I won't tell you what the C stands for. It's a mystery. But let's read the description here. Okay. The Museum of Incredibly Dull Things. So the Museum of Incredibly Dull Things wants to get rid of some exhibitions. Miriam, the interior architect, comes with a plan to remove the most boring exhibitions. She gives them a rating and then removes the one with the lowest rating. So essentially, you are given an array of numbers, and you need to remove the smallest number from that array and return a new array that does not have the smallest number in it. It says here, do not mutate the original array or list. That means we're not going to be directly removing it from the array. We're going to be creating a new array that does not have the lowest value in it. If there are multiple elements with the same value, remove the one with the lower index. So I guess if we look at this instance where there are two ones, which is the lowest value, we remove the first one, but we leave the second one. Cool. Don't change the order of the elements that are left. So they should be in the same order. They should just be missing the lowest one. Sounds pretty doable. And Alka has guessed it right. My first name is Kalamazoo. Hydra is guessing Corn. Corn Jr. I'll go with Kalamazoo. You all can call me Kalamazoo. Cool. So let's talk about how we will do this. Now, my initial reaction is to first find the lowest number, or like find the lowest index. So that's one pass through the array. We find where is the lowest number, and we can do that by having a variable that holds on to the lowest index, and we change it if we find something lower. We have that. And then afterwards, we iterate again and create a new array, skipping the index that we found. I think that's how we're going to approach this. Let's do it. So we'll need a place to store the smallest index. And let's initialize this at 0. So let's first assume that the smallest value is at index 0. Okay. We now need to iterate over the array. And because we're assuming the first one is the smallest, we can actually skip it. So iterate over the array, skipping the first value. And then we'll do a comparison. If the current value is less than our stored smallest value, or the index of the stored smallest value, set the smallest index to be that index. So compare smallest value to current value. If current value is less than the current smallest value, set smallest index to current index. Okay, and now this should handle the situation where there are multiple of the same smallest number, because we're only checking to see if it's less than. So if we come across that that number again, we won't overwrite it because it's not going to be less than, it will be equal to. So that should be good. And so that's one iteration. Now after we've done that, we have the smallest index. So let's go about removing it. So let's say we need a place to store the new numbers. We will then iterate over numbers. If the current index is not the smallest index, push number, or let's just say add number to new numbers array. Should be good. And then after all of this, we will return the new numbers array. Simple enough. Let's see what other names people have come up with. Yeah, Kanto is saying Grand Theft Auto San Andreas. Yeah, I'm the CJ from Grand Theft Auto San Andreas. And hello, Meyer. Welcome to the stream. And yes, you can call me Cal for short. My full name's Kalamazoo. Call me Cal. Or we could be super meta. My name is Coding Garden Jr. Or Code Jr. I like that. Code Jr. Or Carl Jr. I don't know. I think we should have a contest to decide what my first name is, and I'll legally change it to be that. I like Coding Garden Jr. That's nice. Okay, so we have some pseudocode. Let's turn this into real code. If you're new to the show, typically I like to solve it in a fairly verbose way first. We'll use for loops, we'll use lots of stuff, and then we'll see if we can refactor it to use higher order methods like map or filter or different things like that. So let's start here. A place to store the smallest index. We'll need to use let because we're going to be overwriting it. And we're going to initialize it to 0. So we're saying the smallest index is the element in the array at index 0. Okay. Now iterate over the array, skipping the first value. So we're going to do a for loop. We're going to set I equal to 1 because we're going to skip the first value, while I is less than numbers.length. I plus plus. And then we'll do this inside of the for loop. So compare the smallest value to the current value. So let's create two variables. We'll say smallest value is going to be numbers at smallest index. And current value is going to be numbers at I, which is the current index. compare the smallest value and the current value. So we'll say if current value is less than smallest value, then set the smallest index to the current index. So we'll say smallest index equals I. Just like that. Cool. All right, we are on our way. And here, if we just log smallest index, let's take a quick stretch. There are more guesses for my name. Is it Carlos Kelvin? Selvin? Yeah, and if I'm going to legally change it, I probably should do Coding Garden Jr. Alka says Crap Jr., Call Me Maybe Jr., Cranky Jr., Crunk Jr., Can Jr., CentOS Jr., Const Jr. We'll find one. I like Call Me Maybe Jr. That's a pretty good one. Cool. But as you can see, we are logging the smallest index, so we can see what it found for each of the runs. So for the first run, it said the smallest index was 0, and that is correct because 1 is the smallest value in there. For the second run, it said the smallest index was 3, 0, 1, 2, 3. That would have been this one. That's also correct. For this one, it said the smallest index was index 2. That's that one. That's correct. And for an empty array, the value is 0 because there's nothing in it. Let's see what we should do in the case of an empty array. If you get an empty array or list, return an empty array or list. Okay, so we should probably just handle that at the beginning. So say if numbers.length is equal to 0, return an array. Simple as that. But at this point, we've done enough. We have found the smallest index. Now it's just a matter of removing the smallest index. Okay, so we need a place to store the new numbers. So let's call these new numbers is fine. Set it equal to an empty array, so it starts off as nothing. And now we iterate over numbers. Well, I is less than numbers.length. I plus plus. And we will say, if the current index is not the smallest index, add the number to the new numbers array. So we'll say, if I does not equal smallest index, we're going to push it in. So we'll say new numbers dot push. We'll say numbers at I. And let's just put that in a variable for clarity. So let's say current number is going to equal that. And then we'll push in current number. And finally, we will return new numbers. Have we done it? I think we have. We have all the correct outputs. Yay! Yay! And I see lots of suggestions for ways we can make this less verbose and actually like a lot smaller too. Does that mean the same thing? I don't know. Constantine. I could be an occult detective, but I'd have to take up chain smoking. Maybe. I like Constantine though. That's cool. Okay, so this did it, but let's reduce the amount of code that we wrote here. So one thing we can do is, so let's say we still have this code to find the smallest index. That's great. And actually, yeah, so I'm just going to copy and paste it when we write this. So let's keep this code the same for finding the smallest index. There are a lot of suggestions in the chat for basically how we can do this part where we remove that index from a new array. I will show one way I know of doing it. So we need to return a copy. So one thing we could do is say numbers.slice. So numbers.slice creates a copy of the array. Slice actually takes in values so you can get a specific section of the array, but if you leave it blank, you get a copy of the array. And then after we've copied it, we could then splice it to remove the smallest index. And Splice accepts where do you want to remove, what index do you want to remove, and how many do you want to delete. In this case, I'll say 1. So if we return this, oh, that won't work. I have to do it in multiple steps. So I can say new numbers will be numbers.slice, and then we'll say new numbers.splice, because that will remove it, and then I'll return new numbers. Cool. This works. Basically, we copy the array, pull out that specific index, and then return the array. Cool. We could write this in another way, though. Another way to copy an array is to use the spread operator. So we could do this, ... numbers. And what this says is spread all of the values in this array into this new array that I just created. So this will essentially do exactly the same thing, which is cool. Yeah, and Alka is mentioning why that didn't work before. So before, when I put this all on one line, when I said numbers.slice.splice, the reason is splice modifies the array and returns an array of the values that it removed. But my function needs to return the array that we removed it from, not the things that got removed. So that's why I had to split it into multiple lines. Cool. Slice Junior? So that works. That's fun. Okay. Now, this section up here where we are finding the smallest index, I think we can use a reduce. We can turn this into a reduce because we're reducing an array of numbers to one number, which is the smallest index. Let's see if we can actually turn that into a reduce. Oh no, what did I do? Okay. Okay, so we have our for loop. We want to turn it into a reduce. So we'll do const smallest index equals numbers.reduce. Our accumulator, the thing we're accumulating, is the smallest index, so that's our first value. We then get the current value, which is going to be each value in the array. We'll have our little reduce function there. And what do we want to start smallest index at? We want to start it at 0. Now, the one thing about this is this will potentially compare 0 to itself. So what we could do is remove the first value from the array, so that way we don't have to worry about it. Let's just do that. So if we did a slice and we say start at 1, that will skip the first value, so that way our reduce is only reducing over all the values in the array except for the first one because we have the smallest index here. Okay, now what we need to do is basically move the logic in our for loop into our reduce. So we'll say that, and then our reducer will return the smallest index. Now we are trying to use I here, but we don't have access to it. But in a reduce, you can get access to the index. It's the third parameter to your reducer function. So this should work. It's going to take this numbers array, skip the first value, do a reduce over the rest of the values in the array, and then ultimately find the smallest index. Then after we've found the smallest index, we remove it from the array using Splice and return our new array. That's fun. Okay, we're getting there. Yeah, and Alka is mentioning Splice returns an array of the removed elements. So like this removes it, but doesn't return the array itself. So how can we potentially turn this into a one-liner? It's going to be tricky. Yeah, and Alka is suggesting using a filter. I think that might be the way to go. So let's take what we've done here. And now this last part, let's try to turn it into a single line return. So I want to return numbers.filter. So I'm going to filter out any number that, well, any index that is the smallest index, which will only be 1, but we can do it like this. So a filter takes in a function. You get access to the current value and the index. In this case, I don't care about the current value, so I'm just going to call it underscore. I could literally call it anything I want, but I'm just going to call it underscore. And I want to get the current index. And I want to filter for anything where I does not equal the smallest index. And that should do it, because filter returns a new array with all the values that return true for this specific function. So that's great. Our function is getting a lot smaller. We have our reduce to find the smallest index, and then we have our filter to remove that smallest index. Oh, did it not work? I'm seeing some weird behavior here. Let's log our smallest index. So we're getting 0. Yep. We're getting 2. Oh! Yeah. So Alka is mentioning, now that I'm doing this slice thing, I'm getting the wrong index. Because here, this essentially needs to be a +1. Okay, so if I remove the slice, it actually should work. But the reason that was happening was slice made the array 1 length less. So ultimately, the smallest index that I ended up with here was actually 1 less than what I needed. Which means, did the previous one work? It might not have. Yep, the previous one didn't work either. So really, if we get rid of the slice, technically it'll still work. It's just comparing it. It has to compare it against itself for the first time. There we go. So that fixes it. And if I take this solution and remove the slice, there we go. Very good. Okay. Now that we've turned it into this, we can make it a one-liner. Yeah. But I thought slice doesn't alter the length. No, you're right. So like it didn't work in this case either because it changed the length of the array. Now our index was totally off. So I had to remove it in both places. Cool. Okay. Yeah. Let's try to make this a one-liner. So technically, we could reuse this finding the smallest index logic here, but it would have to find the smallest index every single time inside of the filter. I actually don't like that. Can we make this any smaller? Yeah, so I could do this, and it will work. So Yossi is saying use the reduce value as the condition in the filter. So technically, what I could do is put this right there, and it should work, and it does. But you have to think about this. Because there's now a reduce inside of the filter, for every single value in the array, it has to iterate over the entire array. So we've essentially created an n-squared solution, meaning we have to iterate in times. So n times n. It works, and for small arrays, it's perfectly fine. But when you get a really big array, that's where you'll see the issues happening. So I'll just add a note. Yeah. So they're saying we don't have to reuse it. Yossi is saying Code Wars is not about performance. It is on some. So I will say for things like a 7 queue, they typically don't care. But when you get into the 5 or the 4 queues, sometimes they have a runtime limit on your solution, and they try it with really, really big arrays. So you do have to care about performance. And let's make it even one more one-liner-ish. Quick stretch. We can put this all on one line. So we'll say if numbers.length is equal to 0, then return an empty array, else return that. Cool. And the other thing is we can shorten numbers.length to be not numbers.length. So if there is no length, well, if it's 0, that's falsy. Falsy, 0 is true, which would return the empty array. Otherwise, return the other thing. Let's seriously put it all on one line, though. So can we, though? I think we can. So we'll say smallest value goes there. We can turn this into a ternary. So we'll say if current value is less than numbers at smallest index, then we ultimately want to return I. Otherwise, we want to return the smallest index. And that works. Okay. And now we can remove this return statement. Now, I will say the goal is not to get it all on one line, but it is fun to do this. There we go. Nice. Andrew Lane has a one-liner. Let's pull it in and see what he's done. Okay. I'm going to put it on multiple lines just so we can read it. Oh, okay. So to find the smallest number, he's using a sort. It's a cool solution, but I will say this is extremely not performant. Because the sort itself potentially could be n squared. So, oh, never mind. Well, you're only doing it once. So that's okay. If you were doing it inside of the filter, then that would be a lot longer for sure. But okay, so if it's empty, return empty array. Otherwise, create a copy. So we're using the spread operator to create a copy. Then we remove the smallest index by sorting the array and getting the first value. Cool. And using index of to get the index of that first value, and then returned the copied array. Awesome. Not exactly one line. We we couldn't make it one line though because of the splice. Yeah. Yeah, and someone just mentioned name my variable smaller. We're not trying to go for the smallest solution, but if we really did want to, then yeah, let's rename numbers to n. Let's rename smallest index to s. Let's rename this to c. Nice. Look at that. Okay, I'm going to move on to the next one. But the one I am going to submit to Code Wars is this one. I like this one the most. Mainly because it's two iterations, but they're totally separate from each other, so it's not like nested loops. So this is one iteration to find the smallest index, and then one iteration to remove that index. Here we go. Sample tests. It passes. Attempt. And it worked. I'll hang out for a minute or so. Alka says that they have one they'd like me to show. Well, they didn't say that, but I will show it. Because Alka usually comes up with pretty cool solutions. Yeah. And if we are talking about performance, as I mentioned, when you're worried about performance, you don't want things like nested loops. So something like this is like a nested loop in disguise, because a filter is a loop and then a reduce is a loop. So we have a reduce inside of a filter. So essentially it has to iterate multiple times. And this one, if we think about it, to copy the array, that's like one iteration. To potentially to sort it might be close to n squared. We don't really know, but it could be, at worst case. Then to get the index of it, in the worst case, could be n as well. So like this is order n, this is potentially n squared, order n. Ultimately, the whole solution is like n squared, but there's a lot of iteration going on there. Cool. Shea Grant is asking, what is the best place to learn JavaScript? I actually do have a suggestion for that. There's... what is it called? Code with me? Code along? Watch and Code. I think this is the one. Yeah. This is a totally free course by a guy named Gordon Zhu, and he walks you through building a to-do application, but in incremental steps. So you learn about arrays because it's a list. It's a way to store to-do items. This is actually pretty cool. Check it out if you haven't seen it before. I've recommended it to quite a few people, and they all say like they've tried other things like Code Wars and not Code Wars, Code School and various things like that. But this is just a really good thing that like breaks it down really well. So check that out. There's obviously tons of other places online, but that's a good place to start. Okay, here we go. The Alka solution. Ooh. Interesting. Okay, so we're gonna expand this so it's a bit easier to understand. So we've seen this. If the length is empty, return an empty array. That's great. Now we have this reduce. Oh. So Alka here is taking advantage of default parameters to actually have a variable to store the smallest index in. So I think this is what somebody mentioned. How can you find the smallest index and then use it inside the filter? This is the solution, because by having this default parameter here, now he can do the reduce first, which sets smallest index and then uses smallest index in the filter. And we're doing some pretty tricky things here to make that actually work. So you'll see here. So I'm gonna write this on multiple lines to actually show what's happening. And he's using the comma operator to return the second value. So basically this reduce is returning the list every time, no matter what, returning the entire list, so that the return value of the reduce can be filtered on. So that's why he has list set as the accumulator. And then in here, P, the accumulator, is actually the list because that's what it started as. So essentially every time this just returns the list. Because we have this external variable here where we can store the smallest index. So we actually didn't need the accumulator to hold on to the smallest index. And then this is just the logic that says if the current value is less than the value of the smallest index, then we're going to reassign smallest index to the index. Beautiful! Beautiful. I love it, Alka. Cool. Andrew Layton is saying, why not for each? Because for each does not return the array. Ultimately, what we needed was the things before it to return the array, so that way we could do a filter on it. Yeah. Yeah, and default parameters are only supported by a specific version of node.js. So yeah, this is using version 8. I think it probably supports default parameters. And so yeah, you can use them if you want to. There's a question from Chicken Nuggets. Chicken Nuggets asks, can you explain the difference between reduce, map, and filter? I can give you, let's set a timer. I'll give you a 1-minute answer, and then I'll give you some resources on it. Go. Okay. Map, reduce, and filter. So first I would probably start out with for each. So for each is a higher order method that allows you to pass a function in, and that function will get called on every element in the array. And it doesn't return anything, it just gets called in every element in the array. Then you have something like map. Map, you pass a function into it, and that function will get called on every element in the array. But that function returns something. So map takes one array of a given length and returns a new array of a new length using the values inside of the array. Filter takes an array and returns a new array, but of a smaller length. So for filter, you give it a function that if it returns true, the value at that index will appear in the array. If it returns false, it won't. And reduce takes an array and turns it into a single value. So like say sum, you want to take all the numbers in an array and add them together and get sum, that's reduce. And that was 1 minute. So they all have their uses, but as I mentioned, they do different things. Map returns a new array of the same length. Filter returns a new array potentially of a smaller length. And reduce reduces to a single value. You typically see something like sum as the example for reduce, but remember I said it turns it into a single value. So you could reduce an array into an object, or reduce an array into a string, or reduce an array into another array. It's really up to you. A while back, Tony and I did a series where we covered for each, map, filter, reduce. So if you take a look at playlists on my channel, and then take a look at, was it Newbie Tuesdays? I should really make this easier to find. Let's look on the homepage. Okay, let's look at the Newbie Tuesdays playlist. This is bad. It's really hard to find the content. I thought I had a JavaScript playlist. Let's see. Web scraping, CSS challenges, Noob Quest. I swear I had more playlists. Oh well, search coding garden higher order methods. Yeah, there it is. So, but I'm pretty sure there's like 4 videos. Let's make a quick playlist. Because you asked about it, let's make a playlist. Playlists. New playlist. Yeah, this is it's not good. It's hard to find stuff on my channel. Okay, playlists. New playlist. We'll call this higher order methods. Oh. So the first one... Actually, let's see which playlist this video was in. Because I'm pretty sure whatever playlist this video is in also has the other videos in it.
Hello, friends. Today we're going. Hello, friend. Hello, friend.
JavaScript. Yes, where is this playlist? Take a quick stretch. Yeah, so looking at the chat, Alka says, reduce is the ultimate. Danielle says, now explain it in 30 seconds. I probably could. Okay, but yes, I had a playlist called JavaScript, and I cannot find it. I'm going to take the time to do this because, yeah, it should be readily available on my channel. No, I want to search my channel. Why is this so hard? Okay, we go to videos. Can I not just search my videos? Okay, I know what I can do. I can go. I think if I go into Creator Studio, you're about to see behind the scenes. Actually, I'm gonna hide my screen for a second. If I go in here and I go into the video manager. Okay, I can search my videos in here. Higher order methods. For each. There it is. That's the first one. There's a search button? People are telling me there's a search button. Well, when I used the search box at the top, it searched other channels. Oh, I see it. Okay, here we go. It was right here. Now it's gone, but let me show you. This one. Okay. So the first video was on for each. This one. So that'll be the first one. And then the next one was on, I think, map and filter. In each of the videos, we do a review. So that should be the second video. And then we did a video on reduce. And I have a GitHub repo with lots of exercises and stuff like that. Cool. Okay, so I will share this GitHub link. That is the code and like the lessons and the exercises from all of the videos. And then let's just add each of these to a playlist. So we're going to put this one on higher order methods. This one goes to higher order methods. And this one goes to higher order methods. Cool. So they are longer videos, but I'm pairing with Tony, who is the resident noob. And basically, we're going through multiple examples. We have diagrams. He tries to do the problems, and I help him. So yeah. This is the weirdest thing. Okay, noob streams. Can I add a new playlist to it? Well, there's the JavaScript playlist. Jeez, okay. And then we'll also add higher order methods. Okay, can I rearrange them? Yes, let's put that there. Whew. That was way too hard, but now, if you go to my channel and just scroll down, you can see that playlist. So if you scroll down here to, or not, I put it under noob streams, hard refresh. This is so lame. I've spent way too much time on this, but yeah, it's lame. Okay, if you click playlist, you'll see it. So there's the higher order methods video. And for whatever reason, I can't find that JavaScript playlist. But check that out. Check out the GitHub repo. And you'll find it. Ambition says, this is like the professor fumbling with the projector type stuff. Right, and I spent way too much time on it. But I can't, like, there are tons of playlists that I added to this page that are just not here, that I cannot see, and that's not good. Oh well, okay. That was fun. Moving right along. Okay, Kelly can see it now. Maybe it took a few seconds to show up. Daniel says YouTube is gaslighting me. They might be. I don't know. All right, next one is a 6Q. This one is a title case. So let's bring it down locally. And we'll grab the examples. Whoa. Okay, so the point of this one is, given some string, we need to convert each word into a capital word, except for a list of words that it gives us that should stay lowercase. But let's read the problem description. A string is considered to be in title case if each word in the string is either capitalized, that is, only the first letter of the word is in uppercase, or considered to be an exception and put entirely into lowercase unless it is the first word, which is always capitalized. So if you think about like capitalized things, typically words like of, in, the, those things aren't capitalized inside of the word. So that's essentially what we'll have to take into account. So write a function that will convert a string into title case. Given an optional list of exceptions, or minor words, the list of minor words will be given as a string with each word separated by a space. Your function should ignore the case of the minor words. It should behave the same way even if the case of the minor word in the string is changed. Whew. Okay, so let's do this. I'll start up Quokka. There's some discussion about destructuring going on in the chat. Let me catch up real quick. Cool. And hello, Cheddar. Welcome to the stream. Yes, let's have a discussion about destructuring. So in the current project, React project that I'm working on at work, there is a linter rule that essentially forces you to destructure things. Like the linter will not allow it unless you destructure. And I think you would actually even complain about this one. So if you're trying to get at like a nested property in an object, you have to go with nested destructuring on the left-hand side. So what this says and let's write it how you would write it if you didn't have destructuring. So we would say const data equals response.body.data. So this is the old way of doing it. But now with destructuring, it essentially allows you to pluck things out without having to dial down into it. So what this line says is inside of response, there will be a property called body. And inside of that, there will be a property called data. So pull that out. And now, after this line of code runs, we have access to a variable called data. Same thing happens here, but instead of like nested destructuring, we're just pointing at the object and then pulling that specific property from the object on the right-hand side. At work, I have to do this. Like, I can't not do this. But I think they're in the chat. They're just talking about maybe the readability or which ones you prefer to do. Yeah, and Alka is mentioning it allows for defaults and renaming. So let's say you have like two different responses, like response 1 and response 2, and they both have a data object. If you want to rename those variables, you do it like this. And so what this says is inside of this object, there is a property called body. Inside of that object, there's a property called data, and I would like you to rename it to data1 and create a variable called data1. Same thing here. So you can rename them, and you can also do default values. So you could actually do something like this, which just looks so weird. But basically what this says is if body does not have a property called data, or like if it's undefined, it should be set it equal to an object. Or, I mean, you could put null here if you wanted to. But yeah, all kinds of cool stuff. Okay, let's move on to the next one. Title case. Now, we are given the title that we need to convert, and we're also given the minor words. So I think probably the first thing that we should do is convert the minor words into some sort of structure that would allow us to check the words as we go along to see if they are one of the minor words. Yeah. I'm gonna take a drink of water. Okay, here we go. So I think first step is create structure to use for checking if a given word is a minor word. Okay, how are we going to do that? I think the first thing we'll do is we'll split minor words on spaces, because that will give us all of the minor words. So say split minor words on spaces into a new array. Then kind of what I want to do is create an object where the property is the minor word and the value is just like true. So we have like a, and, the, of. So we would take minor words, which is a string, and turn it into this, because now that we have this, when we're iterating over the sentence, we can just check and say, is this word a minor word? And if it is, ignore it. So that's what I want to create. So let's say a place to store the minor words structure, in this case, an object. And then we will iterate over minor words array, and then set property on the minor words structure with the given word and a value of true. Okay, so in doing that, we've created a structure which will allow us to check to see if any given word is a minor word. Great. Next thing is we need to iterate over the sentence and convert each word into capitals, well, capital case. So we'll do just that. So we need to split the title on spaces into a new array. And then we need to, we need probably a place to store the final title. Then we will iterate over that array of words. If the current word is a minor word, then we'll lowercase it. Else, whoa, what just happened? Let's take a quick stretch. What just happened? Okay. Else, we will capitalize the word. And what's involved in capitalizing the word? We to uppercase the first letter and to lowercase the rest of the word. Okay. After all of this, we I guess in here we can say, because we're modifying the words, after we've modified the word, we append modified word to final title. And lastly, we return the final title. Okay, it's a lot of pseudocode. I've been streaming for close to an hour now. So I'm gonna just kind of start coding. I will definitely like clean it up, but I think I will start with some higher order methods. Create a structure to use for checking if the given word is a minor word. Split minor word into spaces into a new array, and start to build out the structure. So we can actually use a reduce for this. So let's say, let's call it check minor words. And we want to take minor words, split it on a space. So this will give us an array. And then we can take that array and reduce it to an object. So we'll do reduce. And let's just call this words. And we get the current word. Here we want to say words at the current word equals true. And we'll return the words. And ultimately, we are reducing an object. So our starting value is an object. And this is what we're doing here. Setting a property on the minor word structure with the given word and a value of true. Cool. If we now log out check minor words, cannot read property split of undefined. Oh, we didn't get it passed in. Okay, so we need to check and make sure minor... yeah, really, we need to check the title initially. If the title is empty, return empty string. So if title.trim is equal to empty space, return empty space. So that should fix that. Okay, and the structure we have now built up has all of the minor words inside of it. Oh, one thing we definitely need to do is to lowercase the minor words. So notice, like in this second case, V and N are uppercase. We want to definitely to lowercase them. So I'll say word.to lowercase. Cool. So now we're ending up with an object that has all of the minor words in it, and we can just check for them. That's great. Okay. Now, we can take the title, split it into spaces, and probably do a similar thing. So we could do a map. Yeah. So a place to store the final title, let's just call it final title. And this is going to be equal to our title split on spaces. So we're iterating over the words. And we'll just map it. So we're going to take each word in the sentence and return a new word that is either capitalized or all lowercase if it is a minor word. So we're just going to do a map. That's going to give us each individual word. And probably one thing we need to take into account is if it is the first word, we always just capitalize it. Like in the case of a Clash of Kings, because even though A is a minor word, because it's the first word in the sentence, it still actually needs to be capitalized. So we do need to take that into account. So let's grab the index and say, let's actually flip this. So we'll say if I is equal to 0, then we're going to return, we'll create a function called capitalize word. Great. If check minor words at the given word to lowercase, if it's there, then we just return the word to lowercase. So if this was a minor word, because we found it, we're just going to return the lowercase version of it. And then lastly, we just capitalize the word. Cool. And this is our logic for capitalizing a word. Let's write a function called capitalize. Takes in a word, and we to uppercase the first letter. So we'll say word at 0.to uppercase. And we're going to append the rest of the word. So I should be able to do word.slice 1. So I want to skip the first letter and grab everything else. And we want to make sure the rest of that is to lowercase. Cool. So this is our nice little capitalize function. It uppercases the first letter and lowercases the rest of the sentence. Cool, cool. I spelled it wrong here. And now if we log final title, this is actually an array of strings. So we see a Clash of Kings, the wind in the willows. But we need to turn that back into a sentence so we can join it. So we'll do join on a space. And now we actually have a sentence. So let's just return this. And we get the correct response for both of these, but notice in this case they're not passing in what's it called? Minor words. So let's just set a default value on there. So if they don't pass it in, it's an empty string, and then this will just do nothing. And it works. Whew. Oh, that's a good call. So Alka is saying if we to lowercase minor words first, then we won't have to do it here. And so that actually would save us some computation because we do it once and then we don't have to do it again. I like that. And actually, we could do the same thing with the title because we're modifying it anyways. So let's make the entire title lowercase, and then do the stuff. I like that. Cool. So that works. I'm gonna copy this and remove all of my comments. Let's see what we got. So we're doing the check for minor words. We're doing this. Okay, so one thing is we technically don't have to build up this object here, we could just check an array of words every time. Let's see what that would look like. So let's just set, instead of doing this reduce, we're just going to keep it as an array. And now instead of using bracket notation, we would say we could probably do if it includes the word. And that works as well. So includes is a function built into arrays that will search the array to see if it has the value that you pass into it. So this works as well. And we have to do less work up front. However, we do have to search that array every time. In this case, it's probably not that big a deal because the array is so small, it only has a few values inside of it. Like that. Cool. And was there a question in the chat? I guess not. Cool. As you can tell, I'm for whatever reason trying to speed things along. I don't know. I guess I've been streaming too long. But this does it. I'm wondering if there's any way we could make it better. I don't know. Kind of like it. Like it the way it is. Let's see what Code Wars has to say about it. Sample tests. That works. Attempt. We did it. Cool. I mean, I probably should have shown this with like for loops and such. It wouldn't be much different. I would still probably want to use something like split because it would be a pain to have to split the word manually as you iterate over it. So this is very useful, doing the split thing. Cool. I'm going to submit it. We did it. Let's take a look at some of the solutions that other people have done. Yeah, so here they're just checking to see if minor words is undefined, then oh, they're returning. Oh no, okay, so if it's undefined, return an empty array for minor words. Otherwise, set it to lowercase and then split it on spaces. They're doing a similar thing to what we did, so they're doing a map. And here we're saying they're using index of. So index of is another thing you can use instead of something like includes. So you could find the index. Index of returns -1 if it doesn't find it, or it returns the index if it did find it. Includes just returns true or false if it was in the array or not. Yeah. Let's check out Alka's solution. Hello, JT. Welcome to the stream. You missed the first two. I still have 2 more to do. Okay. Nice. And again, Alka is using default parameters. So if the title is empty, just return the title. Otherwise, we're going to split the title on spaces, map over it. This is a neat little way to skip over the first index in the array. Because what we're saying here is if I is basically greater than 0, because this is like a falsy thing. So if I is greater than 0, then we're going to check to see if it is a minor word. And if it is, we're going to just return that minor word. If it's not, then we're going to capitalize it. and then we join it all together on a space. That's great. I actually do like that. So basically what's happening is right here. So we're saying if I and here, I'll do it in a, I'll do it here. Then do this, because if I is 0, then we're automatically just going to capitalize it. I like that. Yeah, someone is mentioning that the Code Wars site is pretty slow. It usually is, but I do have the, I think it's called Code Wars Red, where I think it's $5 or so a month, and you get priority whenever your code is running, because it is running in a VM. Chicken Nuggets asked Alka if they used an obfuscator to write it like that. It takes a lot of mental capacity to just write it in one line like that. Typically, I would have to write it out kind of like this, and then like whittle it down to get it into a one-liner. Okay, yeah, that's what Alka is saying they do it. How they did it. Wrote it out normally, and then broke it down and minimized it by hand. Cool. Awesome. All right, let's move on to the next one, which is going to be fun. We're going to build a ROT13 decryptor. Translator, decipher, cipher. I don't know. Okay, so how can you tell an extrovert from an introvert at the NSA? And the joke is that this sentence here has been ciphered using a ROT13 cipher. And if we look at a ROT13 cipher, essentially, it stands for rotate by 13 places. So each letter is 13 places after the actual letter, and it produces gibberish. But to decipher it, you essentially just have to take that value and move it back 13 spaces, and you'll end up with the original value. Yeah, and in this case, we're only supposed to substitute characters, so anything that's a space, a punctuation, or number, we can ignore. And so we're given something that's in ROT13, and we need to return the deciphered string. Let's try it out. We don't have any example test cases here, so that's sad, but we can use what they have here. Cool. And I guess the interesting thing about ROT13 is because there are 26 letters in the alphabet, it's a cipher and a decipher. So if you put something into ROT13, it's going to output, well, I guess any cipher would be. I don't know, but notice how we're putting in something that's ciphered and we get out something that's legible, and if we put something that's legible, we get out something that's ciphered. Cool. Let's start up Qualcomm. Alka saying, can you post the sample in the chat so I don't have to write that out? Oh, these? Yes. Is that what you meant? Hopefully that's what you meant. Cool. So, how are we going to do this? Let's write some pseudocode. We are going to iterate over the string. We need a place to store the deciphered text. iterate over the string. If the current letter is a character, we need to get 13 letters after it. How are we going to do that? There's multiple ways. And then we will append the deciphered letter. And if it was not a character, we just append the... I called it a letter. Let's say if the current value is a character, so append the value. Yeah, cool. And then after all of that, we return the deciphered text. Cool. One thing we could do is use the, is it the Unicode values? But the char code values. So in JavaScript, every character has a character code. So we can do char code at 0, the index, and we get back the character code. If we do, let's say, A, the character code is 97. And if we say that plus 13, we get 110. And I think we can do we can turn a char code into a letter. How do we do that? Say JavaScript char code to string from char code. Yeah. So if we say, is it string.from charcode 110, we get the letter N. So what we can do is we could get the character code of that specific letter, add 13 to it, and we'll get the encoded character code, and then we can convert that back into a string. Now, this will be a little bit tricky because you'll notice we're working within a specific subset. So capital A is 65 and capital Z is 90. So that's 26 letters total. But between 65 and 90 is our capital letter space. And then lowercase a is 97. And lowercase z is 122. So that's our lowercase character space. So when we're converting these things, like if I add 13 to 90, I actually need to wrap it back around to 65. So we're gonna have to do some maths. Oh yeah, and Alka had it, string dot from charcode. So you pass the charcode in there and you get back the string. Okay. I just want to double check, like if we get uppercase, they need to be uppercase in the conversion, and if we get lowercase, they do need to be lowercase in the conversion. So this whole bit of logic here is really going to be where the meat of the code is. Let's go ahead and get like the skeleton code, and then we'll figure out how we're going to write this. So let's say deciphered is an empty string. And then we're going to iterate over the string. And we're going to have each value in the string here. If the current value is a character, well, we could use like a regular expression or something like that, but we also know the character code ranges. So if we got the character code of the current letter and made sure it was within these ranges, we would know that we need to convert it. Otherwise, we don't. So if the current value is a character. So let's say, let's create a variable called charcode. And we'll do value dot... Well, actually, we could do string dot char code at I. And so that'll give us the character code of the current letter. And then we need to just check to see if it's within this specific range. So if character code is greater than or equal to 65, and character code is less than or equal to 97. Is that, no, 90. So we're saying if this is between capital A and capital Z, we'll do the thing. Whoa, whoa, whoa. Now let's check and see if it's a lowercase letter. I think we're going to have to do these separately because our math is going to be a little bit different. So we'll say if char code is greater than or equal to 97, and char code is less than or equal to 122, which is our Z. We're going to do that. Else, we just append the value. So if it wasn't within those ranges, then that means it was either like a space or a special character or something like that. Else if. So here we'll just say deciphered plus equals value. So we're just going to append that to the deciphered value. Ultimately, we will return the deciphered value. And we can see it's at least working for things that are not letters. So here we get back 13 and a period because those are the characters that were not letters. Okay. Now, how do we get the next value? So if it's a Z, I actually want it to be, what is 65 plus 13? 78. So if we get a capital Z, which is a 90, if we add 13 to it, so let's say 90 plus 13, we get 103. If we subtract 65, do we get the number? No. But really what we need to do is wrap around. So we could do this. We could shift the value back down into like the 26 character space, so like 0 through 26. Calculate what the new value would be within 0 to 26, and then add that onto 65, because that'll give us our capital letters. Yeah. Oh, interesting. Alan is suggesting, and like that's a easy way to do it. So A through M, you just add 13, and into Z, you subtract 13, because there's 26 letters, so it wraps around anyways. I kind of do want to wrap around, though. Let's see if I could write the math to wrap around. So let's say cipher. That's not how you spell cipher. How do you spell cipher? Say char code plus 13. And in this case, we need to wrap it back around to be within 65 and 90. So let's do this. We'll say char code minus 65. That's going to put it between 0 and 26. Okay. We're going to add 13. And then if we do mod 26, that will put it within the 0 to 26 space. And then we will add 65 back onto it. So, in the case of A, capital A, which is 90, we get back 77, which is wrong because it needs to be 78. So my math is off by 1. Do we need to add 66? what is 13 mod 26? It is 13. Cool. And that should give us 13 plus 65. Yes. Oh, I'm trying a case that's lowercase but using the uppercase code. Okay, sorry about that. Capital A is 65. Yes. Okay. So if we give it 60, there we go. Okay. So yeah. So this works. I like it. Okay. Cool. No, I think yeah, you're right, Alka. I was testing it with the wrong thing. So this works. This works. So now we can say deciphered. I didn't spell that right, did I? Deciphered. We're going to append string dot from char code cipher code. Cool. And now we do the same thing here, but we start at 97 instead. Okay. I think we've done it. Yay! Cool. Yeah. So this works. I do like the suggestion that that Alan made though, where we either add 13 or subtract 13. That would definitely make this logic a lot easier. Okay. We could turn this into a reduce though. So let's just do that real quick, because we're taking this string and reducing it to this string. So let's do that. Now, the issue here is string is not an array, so it doesn't have a reduce method on it. We could split it on the empty space, or we could like call the reduce method on the array prototype. Let's do that. So we'll say array.prototype.reduce. We're going to call it on the string, and we're going to give it a function which is going to be accumulating the deciphered value, and we'll get access to each individual value, and we'll also have the index. Our reducer starts off as an empty string, so I'm going to pass in empty string there, and then we just do all of this. In here. But really, because we're doing the reduce, we can just return it. So we can say return deciphered plus that instead of plus equal. There we go. So we now have a reduce that's doing the same thing. Yep, that's about right. Oh, wow. Alka has a one-liner. I'll definitely check that out. And see you later, RabbitWorks. Thanks for stopping by. Okay, we'll check out his one-liner once I get this going. Cool. So reduce works, but now let's try it with what Alan suggested, where if it is A through M, just add 13. So let's figure out what a capital M is. $77. So, oh, we don't even need that. Yeah. Okay. So, what is happening? Come back. Okay. If char code is less than 65 plus 13, less than or equal to, less than or equal to. If it is less than or equal to that, then we want char code plus 13. Else, we want char code minus 13. I think that's the logic, because we're saying if char code is between 65 and 77, we're going to add 13 to it. Otherwise, we're going to subtract 13 from it. Cool. And then we have similar logic here, but it changes. It'll be 97. Oh, messed up somewhere. Do I need to do less than instead of less than or equal to? Yes, I do. Okay. But this works, so we don't have to do that weird like modulus math. If it's less than m, just add 13, but if it's greater than m, subtract 13. Cool. And that seems to work. Cool. Cool. Hello, Justin. Welcome to the stream. Justin says, after following you for the past few weeks, it's awesome to finally watch you live. Welcome. Also, shout out to Daniel at the Coding Train for introducing me to your awesome channel. Yes, definitely shout out to Coding Train. It's a great place. Let's see. Okay, yeah, let's take a look at Alka's one-liner function. Oh, Alka is also suggesting I could just, instead of comparing the character code, I could compare it to the value. Yeah, so if value is less than capital M, actually, I'll do this in a separate one. Okay. If value is less than capital M, or if value is less than lowercase m. So this is something you may not know. When you do a like a less than or greater than comparison with strings in JavaScript, it's actually comparing their character codes. So this works. Nice. Good suggestion. See you later, chicken nuggets. Have a good night. All right, yeah, let's check out Alka's one-liner. Whoa. So they're using a regular expression. Oh, nice. Yeah, so this is another cool feature you may not have seen before. So JavaScript's replace function, typically you see it like someone might call replace with like A. So replace all letters with the letter A. But you can actually give it a function, and that function will get called on anything that matches and replace it in the string. So that's what we're doing here. So any letter A through Z lowercase or A through Z uppercase that's in the string, we're going to run this function against it to see what it should be turned into. And so we have m, which is the character that just got matched, then some variables that we don't need, and then a default parameter that is the actual character code. So if the character code is greater than or equal to 97, then we just use the value. Otherwise, 65. So we're trying to determine what is the starting value, similar to what we were doing here. Should we be starting at 97 or should we be starting at 65? Is it uppercase or is it lowercase? That's cool. And then we do the modulus math. So we say, we take, this is basically the math that I came up with up here. Where is it? Yeah, so take the code, subtract the initial value, if it's uppercase, the initial value is 65. If it's lowercase, the initial value is 97. So I think we're doing the same thing here. Yeah, so we take the initial value, subtract it, add 13, and then mod it by 26. Very cool, Alka. I like it a lot. I really like the use of the regular expression because essentially you're running this function on any letter in the string. I like it. Okay, so here the parameters to the function are match, offset, and original string. And then taking advantage of default parameters and saying, well, I know that they're not going to pass a fourth parameter in here, so we're just going to use, we're going to create a variable that is its character code. Cool. Hello, James Phillips Media. He just says CJ. Cool. Did I submit this on CodeWord? I did not. All right. So I'm going to submit my one with the modulus because I'm pretty proud of coming up with that all on myself, all by myself. So yeah, I'm going to submit this one. Oh no! Oh yeah, because there are no sample tests. Okay, we'll do an attempt. There we go, it passed. So this is using a combination of the regular expression replacing and the either adding or subtracting 13 based on where the letter is. Now, this one, because it's doing case insensitive. I see. Because they're only checking for lowercase. Interesting. Okay, last one of the night, stripping comments. I'm hoping that I can get this done with just a simple regular expression. It won't be too much, but... What, train again? What? I've never done this before, have I? Yeah, I've never done this. I don't have the solutions unlocked. Okay. Yeah, definitely sure I haven't done this before. Okay. Let's bring it down locally. So essentially what we have to do is we're given a string, which could be like code or something like that, and we have to strip out all of the potential comments. So you're given an input, which is something like that, and then you're given a string of, or an array of all the possible comment markers. So in this case, if we said comments begin with a hash or an exclamation mark, the output should remove anything that was after those specific markers. Okay, so let's see some examples. Put those down locally. Inputs, markers, and then the expected output. Okay, start up Quokka. Oh, we want to call solution. So I guess, for example, this is the example input that they gave us. So you have, this is our input with like new lines and all. And then our comment markers are either the % sign or the exclamation. So everything after the percent sign should get removed, and then everything after the exclamation should get removed. So the result is that without those specific comments. This one is a little weird because our comment markers are the @ sign and the minus sign. So essentially what we need to do is we need to match from the comment marker up to a new line, and we'll remove everything but the new line. And then if we find another comment marker like this one, remove up to the new line. Remove up to the new line and only leave what was there. So you end up with Q, U, and E. Cool. All right. Let's take a stretch. Let's code this thing. See you later, Danielle. Have a good night. Okay. Yes, so what I'm thinking is we have a regular expression that matches against the marker up to a new line, replaces that with simply a new line, and we're done. Let's just do it. Okay. We need to build up the regular expression. So markers is an array. So let's do this. So we're going to create a regex. This is going to be markers dot join. And I want to join it on the pipe command. Yeah, so because this is going to create a regular expression that matches either of the markers. So I want either of the markers followed by pretty much anything followed by a new line. And this or should be wrapped in parentheses. And I need to escape the new line, so I should actually see the new line. Yep. And it should start with 0 or more space. Followed by a parenthesis. Oh yeah, Alka is saying I have to be careful generating a regular expression. Yeah, like, oh yeah, so I actually need to escape whatever they pass in here, because markers, like something like the exclamation mark, might actually be a regular expression value. Yeah. Here, I'll share these examples with the chat. Yeah, so not only do I need to join them, I need to escape them. So I really want to do a map. Each marker, I want to escape it, even if it doesn't need to be escaped. Oh, that's the wrong escape value. Other way. Yeah, so the regular expression I'm generating says match 0 or more spaces followed by either a % or a exclamation point followed by 0 or more things followed by a new line. And I think the new line is optional because, like in this case, we need to replace all of this with nothing, and there is no new line here. So to make the new line optional, I think I can do a question mark. Let me double check. Yeah, I think it's the question mark. Optional. Okay. So if I do input dot replace a new regex expression with the regex. Definitely didn't do it. So like in this case, I needed to get, oh, undefined? What's happening there? What is undefined? I don't know. Let's see what happened with the first one. Apples, plums, undefined. Oh, is it trying to reference a specific value? Q undefined. It happened here too. So basically, the specific thing that it's using for the match is coming back as undefined. Oh! Like that. Okay. Oh, but I want to replace it with a new line. That didn't quite work. I guess if it was a new line, I need to replace it with a new line. Whew. Okay, let's see what happened, though. Because this is QUE, and then I'm actually missing the second one. So it's not replacing that one. Do I need this in square brackets instead of parentheses? But you'll notice it is working for the first comment that it finds with the first marker. But if we're using the other one, it doesn't work. Yeah, so definitely needs to be, Alka is confirming, it definitely needs to be in parentheses. We do need to do we need to do a global replacement. Is that all I need? No way. Did this work? There's no way this worked. It didn't work because in the case of this, it replaced this with a new line, but it shouldn't be a new line. So I think I need to be a little bit more careful here. So I think we can do this. We get the match. Yeah, so we can say something like, if match ends with a new line, return a new line. Otherwise, we return an empty string. So yeah. Is ends with a thing? Yeah, it's not complaining about ends with, so I think that's a thing. The only tricky thing is my console logs here aren't displaying the new lines. Let's run it. Apples, plums, pears, oranges, and apples, plums, pears, oranges. QUE. I think it's working. I think it's working. Let's try it. This could fail miserably on CodeWars because if I'm not escaping my regular expression correctly. Does that work? Andrew is suggesting we can create a regular expression dynamically just using the markers. Let's see. It works for the sample tests. Let's go. Full test. No way. No way. That's I can't believe I did that. It's pretty cool though. Yeah, so I dynamically generate a regular expression and then run that regular expression on the input. We basically just built a comment parser for a new coding language. Hey Amy, welcome to the stream. Oh, no worries. It's been a fun stream. I just finished the last one. I surprised myself that I was able to do it. Interesting. Yeah, so Andrew Lane, I believe, I don't know, can you use variables in regular expressions? I definitely have never done that before. Thank you, Alka. Thank you for the applause. And so this is I didn't talk about it, but this is the reason that I created a regular expression. Is typically if you want to use a variable in a regular expression, you have to like create one. So what Andrew is suggesting is basically we can like, or try to create a regular expression in line. So basically it would be space followed by markers. Yeah, and I don't think this will work because the regular expression interprets this as like the letters M-A-R-K-E-R-S. It's not actually the variable. So that's why I had to do this, like create a regular expression object that you pass a string into. Oh. That's a good point. So Alka was saying, like, what if they tried to pass in / as a comment, which should work, but I think you would need four slashes because they're escaped. And then technically, I couldn't just start the first one with the slash. Yeah, that would have been really weird. But their test didn't do that, so I guess I didn't have to worry about that. Yeah, that would definitely broke if they did that. Oh, no. This would have been / so I would have had to escape. Yeah, so you need to like, if the marker is multiple characters, you map over the multiple characters to escape them. Yeah. Yeah, and they didn't put any extra test cases in. Oh, well, I'm happy with that. I've been streaming for close to 2 hours, so I think that's a good note to end on. Let's look at some of the solutions people created. Yeah, so like they created a dynamic regular expression. Here, they're not escaping the markers. They're just joining it on the empty string. Interesting. In this case, they first split on new lines, so then you're only dealing with one line at a time. Yeah. No regular expressions at all. split the line on the marker and just take the first part and trim it. It's actually a pretty simple solution. I like that. Yeah, and then this person is like added an actual regular expression escape function. Well, an escape function that will escape a given string. So these are all the special characters and regular expressions. So you want to, if a marker was potentially one of those special characters, you'd want to escape it first. Yeah. Hello, Mahmoud. Welcome to the stream. Alka saying their solution is the second one. So basically this one, where you, and that makes sense. Like, look at it one line at a time and then just split on the first occurrence of that special marker and you're done. All right, last stretch of the night. It's been fun. Yeah, this was Code Katas. I will push all the code up to GitHub so you can see my solutions. I hope to do this again next week. So if you have any suggestions for Code Katas for me to do, feel free to add them as a comment on this issue, or feel free to open a new issue on here with a suggestion for katas you'd like me to solve. Not going to say for sure, but I actually do want to stream a couple more times this week, so look out for that. If you just take a look at the channel, if I do decide to stream tomorrow, I will put it on the page here so you can actually add a notification. It'll pop up right here. And I think that's it. I did create some new playlists today, so if you are interested in learning more about like map, filter, reduce, and stuff like that, check out this higher order methods playlist where there are some streams from a while back that me and Tony did to learn about map, filter, and reduce. And hello, Ran. I'm on the way out, but hello. Cool. I think that's all. I'll push this up to GitHub. Thanks for watching. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. We'll see you next time. Here's this.